Hi, everybody. So, welcome to this first session, the inaugural session of this series of talks organized by Campus Creativo from Universidad Andrés Bello. As you all know, Actuar por Bienestar is an initiative, a workshop that will last the whole week and that will involve students of different disciplines, all part of Campus Creativo, with the intent of course, seeking out new ways of interactive proposals with the environment to have speculation, new ideas on well being, and based on the policies and economics at the international level. For this first talk, I have the pleasure of introducing the EcoLogicStudio offices. I'm sure many of you already know about them. Ecologic Studios is almost a biotechnology lab and architectural practice focused on innovation, design, focused on biotechnology for the building of spaces. So it's not, so it is an office founded in London, 2005, by its two members here, Claudio Pascual and Marco Poletto, who have built a unique portfolio of biophilic structures, live architecture, and urban planning that considers water and the earth as symbiotic and independent bodies. In 2018, after, well, almost 15 years of professional practice, they joined Landscape Lab and Morphogenesis Lab to create Photosynthetica as a company, which has developed a photosynthetic film or layer for buildings, and this helps with CO2 and contaminants and pollutants in the air with the use of algae. I'm sure they'll tell us a little bit about that. They'll give us further details on these topics. It's also important to, well, comment that this is a practice that has been developed in academia. Both are doctors, academics, well linked to architectural associations, a collaboration that, without a doubt, belongs also to La Barlett, Innsbruck University, and the IAFE, the Advanced Architectural Institute of Catalunya. Together, they develop scalable solutions based on nature for the imminent impact to stop the imminent impact of climate change and developing an inventive, creative way of seeking contemporary manners of working in carbon neutral. It's a pleasure to welcome Marco and Claudia, and I give them the floor and welcome them. Please go ahead.
Hey, thank you, Esteban, for the great presentation. And of course, it's a pleasure to be here, even if only virtually on this occasion. But I hope that it will still be a kind of entertaining hour or so together. So I will share the screen now, so we don't waste too much time, and we go straight to the presentation. I think we probably don't have to repeat much of the introduction because it was already done very well. So maybe I just kind of highlight a few of the key achievements that sort of define who we are at the moment. And essentially, as a design innovation company, we really exist across these two domains of the artistic and the speculative on one side, and the scientific and the technological on the other. And I think our main focus, main interest has been to find a common matrix, a common ground for these two ways of understanding and engaging with nature and the built environment. So you will see during the lesson, we will show some of the key projects. One, for example, is the biodigital design framework, and in this case, the sculpture presented in Saint Pompidou. And urban well-being is another topic that we have been engaging with, and especially we built the first permanent biotechnological dwelling in Astana. Future food, of course, intersects with architecture, urban design more and more. And we were, I think, the first to integrate algae farming in a canopy in Milano in 2015. And finally, the paradigm of carbon neutrality, which is, of course, everyone's topic these days. And it has been part of our agenda for several years. And perhaps the most well-known approach to this topic has been the Photosynthetica project, which won several awards. Why are we doing all these? Of course, on one side, we have been always very passionate about architecture and design, but I think on the other hand, there is a sense of urgency these days in terms of promoting a real paradigm shift in the way cities work and operate. And I think the most fundamental transition is to shift from what we call metabolically linear city, which is essentially fed from resources that come from very far away and then generates waste that also is disposed often very far away from the city centers itself, to a new model of circularity that is capable of effectively closing this loop. Again, I'm sure you are familiar with some of these statistics, which somehow are urging us to consider what can be done with a growing urban population, but also a growing rate of urbanization, which are still happening despite the latest development. And again, cities are also still the bigger emitters when it comes to CO2 emissions. And this is because, as I mentioned before, they are at the moment often relying on a huge amount of resources coming from the outside and feeding their hungry metabolism. And that, of course, leaves traces in the atmosphere, in the soil, in the water, contaminants in the air. Even in a city like London, are still very, very high and worrying for several people. So the main question that we are asking ourselves is, can we convert what cities expel as waste and pollution into healthy superfood and sustainable materials for a growing urban population? Is it really possible to achieve these kind of circularities where cities and the built environment become real engine of transformation? And of course, we believe that that's possible, and we believe that architecture and design have a role to play, a very important role to play. And that's why we have created this Photosynthetica project that, as I mentioned, or as Esteban mentioned before, operates across research, academic research and practice, and brings together the two laboratories, which together with Claudia, we are currently directing. So Photosynthetica really attempts to create new circular economies of information, matter, and energy to remetabolize cities and balance carbon flows globally. The core ingredient of Photosynthetica project are photosynthetic microalgae, which are one of the oldest organisms on Earth. And what is interesting is that despite us paying little attention, microalgae are essentially everywhere, in every water bodies, every river, canal, lake, sea. We find a rich microbiome of organisms. And precisely because they are ubiquitous, they are in fact the world's largest carbon sink, more than the trees in the forests. And they are in that way one of the key powerful links to the continuous transformation of the atmosphere. In fact, we could argue that they are the key organisms that in the old times provided the ingredients of the atmosphere that we breathe today. So from the perspective of these organisms, what we consider pollutants like nitrogen dioxide or even carbon dioxide itself, which we can't breathe, for them, these are nutrients. These are some of the building blocks that the cells of microalgae use to multiply and create new biomass. So one of the fascinating aspects of bringing the cultivation of these organisms in the built environment is there is a real opportunity there to create a new symbiosis between our species and the microbiome and the richness of the microbiome and the intelligence of the microbiome. So essentially, in that sense, for us, the connection between design innovation and science has really the possibility, the ambition to design artificial habitats that effectively allow us to grow and cultivate these organisms collectively within the city, within the urban realm. And here are some examples of a few applications. We will go down more in detail later on some of these projects. Again, one of the key aspects is that our solutions or the design implementation we have developed bring nature beautifully and efficiently to contemporary cities, turning buildings into living machines that produce energy, store CO2 into valuable biomass, and clean the air. So the circularity here, it's not just a question of pure technology or pure efficiency, but it's really about the possibility to create a new interface where beauty becomes a measure of ecological intelligence. And this is one of the installation in Dublin of the photosynthetic membrane. So to get an idea of the potential of the microbiome in it's, you know, it's kind of useful to trace a comparison between cyanobacteria and trees. And when we look at the membrane we have developed, we can see that the amount of carbon dioxide that 50 liters or kilogram of cultures can absorb is equivalent to the one of a mature tree. And so despite the tree occupying a lot more space and being a lot heavier and a lot more difficult to integrate in a built environment, the carbon performance is the same. So this means that we can potentially create much more effective ways of capturing carbon through nature-based technology if we look at the microbiome as a starting point. So when the system is integrated in the built environment, also brings additional advantages than when algae grow in the wild. And in particular, key benefits are the possibility to reduce the energy consumption of the buildings themselves, improve the urban air quality, capture carbon, as we said, and produce biomass that can be used locally. The mechanism, of course, as we mentioned before, is a photosynthesis. So essentially, this whole system is driven by the renewable energy of the sun. And the way the design of Photosynthetica operates is to try to expose the algae in an optimal way to the solar radiation so that the photosynthesis progresses effectively and the conversion of pollutants into biomass also operates at the highest rate. And of course, the byproduct is oxygen, which is released in the atmosphere. This video shows the system in action as a part of the project we developed. This is already 5 years ago, the first version of Photosynthetica membrane in Milano. And as you can see, the system effectively uses the canopy of this pavilion as a surface. And so again, we create this possibility for symbiosis whereby the canopy shades the visitors or the people hanging around, and protects them from the sun, while at the same time capturing this radiation to operates photosynthesis and therefore remetabolize carbon into biomass. So again, this is the possibility that we envision in multiplying the effects, in achieving a higher level of integration between the microbiome and the urban systems. This is a kind of quick summary of how the system works, but I kind of already mentioned it to you. Essentially is a question of bringing as much air circulation in contact with the living algae, and then of course optimizing the exposure to solar radiation. These are two aspects are the one that drive the engineering of the system in terms of optimizing its performance. And of course, as I mentioned, the byproduct are valuable biomass and oxygen. So maybe I repeat myself, but I think one of the key aspects of nature-based technologies are that, differently from conventional mechanical systems, they allow us to create really new metabolic system in the cities. So powered by the sun, the algae capture and store the CO2 molecules and air pollutants into biomass, enabling new circular economies on food and biomaterials. So we can create filters effectively that are not just simply trapping the pollutants and then creating waste material that you need to landfill, but really we are creating new metabolic systems that become beneficial to our urban metabolism at large. And of course, we are also beginning to explore different material processes, how we can effectively make use of the biomass. And some of these you see, for example, one on the back on me here in the studio, creating bacterial cellulose, using the biomass we grow in the reactors, or effectively bioplastic mixtures. Algae-based bioplastic is also seen as a very important resource for the future, and even integrate these into 3D printable filaments for design applications.
We are now so many, and our impact on the biosphere is so large, so vast, then the biological systems cannot adapt fast enough.
We have therefore designed inhuman gardens as a form of interface between multiple forms of intelligence, human as well as non-human, and between the built environment and the natural one.
So this video was introducing one of the projects that we developed recently as a part of our collaboration with the Synthetic Landscape Lab at the University of Innsbruck. And it's a kind of demonstration of how these two paradigms that I was mentioning before are fusing or combining. So on one side, the structure is, of course, a test bed for technology, and in particular, in this case, bioplastic 3D printing on one side, and on the other side, the possibility to use 3D printing, 3D printed structure as a substratum for microorganisms to grow within them. But on the other end, as you can see, the project is also very much an attempt to express aesthetically the intelligence that the system embodies. So there is a new paradigm here where, let's say, the functional aspect and the aesthetic aspects are no longer opposites, if you want, but that they are reinforcing each other. And I think this is something that also we can learn from the observation of nature and natural systems, where often we realize that the beauty of a system is a measure of its ecological intelligence, of its health. And we believe that's a paradigm that can be translated to design and to architecture quite literally, where essentially we can express aesthetically the ecological functions and intelligence of the system itself. Here are some of the photos of the inoculation phase. We often end up designing also our own tools and techniques of how to bring processes that normally take place in the lab and how we can bring them out in the urban realm, or in this case, it was a museum context in the Saint Pompidou in Paris, but it's still an interesting step towards wider adoption of this technique. The project then was exhibited in Tokyo and the Mori Art Gallery, which is a quite extraordinary place, high up in the sky, the 58th floor, the Mori Tower overlooking Tokyo. And this project really gave a whole other dimension, I think, to the experiment. And we started to imagine and to speculate about the possibility of this organism to take the scale of a tower and become essentially a really powerful agent of transformation in the urban realm. And so not only of environmental and microclimatic transformation, but also in the possibility to enable the emergence of a whole set of new practices and programs that would take place within this thick membrane or this thickened structure, and essentially make use of the available biomass and the resources that the building itself is producing, is generating. So all of a sudden, building a tower is no longer just a container of functions, but becomes itself a kind of new metabolic unit that synthesizes resources, that enables new processes, new practices to take place. And of course, this has a series of significant values that may become really important when it comes to the economic feasibility of these solutions. And if we compare this with other nature-based solutions that we are seeing these days, using microalgae organisms and microbiological systems bring significant advantages in terms of lower installation costs, lower maintenance costs, no loss of leasable space, added value in the biomass production and in the data that the system is creating. But of course, it also brings the possibility for new typological conditions, new spatial organizations to shape our future cities. And especially, we have come to realize these days that the rigid segregation between leisure spaces and productive spaces, or between work and living, is obsolete. and needs to be redefined and redescribed. And I think that's exactly what this type of approach can bring in the moment that we, as architects and designers, can begin to envision the possibilities. So this was a kind of introduction, if you want, to the approach of the practice and the technology. But now we will look a little bit more in detail at some applications or some case studies of projects that we have developed in the last 3 years, and that demonstrates how this technology is no longer just a kind of a speculative or research project, but it is effectively a reality now. And so it can be applied and it can begin to have an impact. So one of the projects is the Biotech Hut that we have completed now 3 years ago, and that is a kind of prototype dwelling, a biotechnological dwelling, and that's kind of demonstrating the possibility of the application of these systems to the public realm and the retail environment. And here the pavilion was divided into 3 areas, demonstrating different ways of interacting with nature. So the science lab was a part of it, describing the energetic potential of this. And then we had the living space, which was the area of experience of artistic interaction, dominated by this sculptural piece that we produced. And also the area where the symbiosis between man and organisms was tested in terms of oxygenation and carbon capture. And finally, the garden production area. This was the area where effectively the harvest of the biomass was taking place, and where we were effectively measuring the proteic and the future food nutritional value of these projects. And of course, this could be a significant aspect in terms of reducing emission connected with the farming industry, which is another sector that, of course, is responsible for much of the footprint of contemporary cities. And again, the spatial dimension is important to realize how these systems can be integrated in the architecture in a way that is not only producing novelty, but also it is very effective in the occupation of space. This is a diagram of how the system were organized and how the circularity of the algae farming would also engage with the spatial organization of the building. And this one is a very recent project. We just completed this 6 months ago in Warsaw, and I am very proud of this because it was not easy. It's a playground, so it's a structure that enables kids to play and have fun while immersing themselves into what is effectively a pollution filtering machine. So the playground itself is integrating 52. The playground itself is integrating 52 reactors, which contains 500 liters of cultures that are filtering the pollutants out of the air. We collaborated with a client that is Otrivin, a large pharmaceutical company, and this project was part of a campaign to raise awareness on the effects of air pollution on children. Here is a video produced by the campaign team.
I feel stuck in the middle. Do I send them out to play in pollution or keep them locked up inside?
Is a major problem. Pollution levels are far worse at the child's height. They are more sensitive to the detrimental effects of air pollution.
We all grew up going outside and not having to worry about things.
I never thought I'd have to protect my kids from the one thing that keeps them alive.
As a mom, it breaks my heart.
I just want to play.
Microalgae are incredible organisms. And with our technology, we can use them to clean our city's air. We have gone to one of Europe's most polluted areas and built the world's first air-purifying biotechnological playground.
The uniqueness of this concept relied on the relationship between the architecture and the kids.
Have fun there.
The more children play, the more the algae absorb pollutants and clean oxygen is released.
This algae is what's taking the bad stuff out of the air.
The air feels amazing.
The key aspects of this project is to create awareness that it is indeed possible to clean the air we breathe.
This can't be the only way to help them breathe better. We need to do more.
Can we come back tomorrow?
So yeah, as the video was pointing out, the project actually moved from a very important brief, which is highlighting the effect that air pollution has on children, especially in big cities, where often the kids are the most vulnerable to the effects of these. And so the idea was to create a structure dedicated to this problem, but also to demonstrate how, again, with nature-based technology, we can create machines that are no longer separated or segregated from the urban space that we inhabit. So we can even imagine that air filtering machine is a fun place to enjoy and to play within. Here you see some of the photos from the outside and the inside. The structure is essentially a timber cylinder which integrates glass reactors for the culture, and it's enclosed by a very thin ETFE membrane that helps creating this internal microclimate of clean air. And the roof itself is designed to stimulate air circulation and avoid overheating. And of course, then there are ropes and bouncy balls and other equipment for playing. This is the diagram that describes the kind of exploded view of all the layers and all the systems that are integrated in the playground, the structure itself. Something that is quite important, unique of this project is that we have also actively integrated air pollution monitoring in the project itself. In fact, we have 3 sources of data. One is the city weather station in Warsaw. One is a pollution monitor outside of the playground, and another one is a pollution monitor inside of the playground. So we are constantly logging data from these 3 sources and compare them. And we are producing every week a bulletin that highlights the percentage of reduction in pollutants concentration that we are able to achieve with our systems inside the playground. And what we have discovered in these 6 months is that we are actually able to reduce it by almost 80%. And we are in this way bringing the concentration of pollutants always within the green zone, the recommended healthy limit of the World Health Organization. So essentially, we are able to achieve a level of air pollution that is considered completely clean inside of the air bubble. And this is despite, of course, the atmosphere of Warsaw being one of the most challenging in terms of concentration. This is also a project that very recently we have installed. It's a different context. It's the Corderie dell'Arsenale for the Venice Biennale. Some of you are probably familiar with this incredible space.
So this, in a way, represent the museum application of this photosynthetic project. It's divided in 3 areas. You can see here the curtain, the vertical curtain, where we grow, inoculate the microalgae. It's a space for living for non-human organisms. And this is the first space that also act as a filter of the outdoor environment and connect to the vertical garden and the convivium. The vertical garden is the area that contains 15 photobioreactors, 15 biobombola, and produce spirulina for daily intake of a family of 4, while the convivio is the area of pleasure of both degustation but also visual pleasure. And in this case, we have developed this with Swarovski, this glass 3D printed glassware. Each of them has the same protein intake of a T-bone steak, and therefore is able to provide for the family. This is the vertical garden. The next prototype is the biofactory. How can microorganisms become part of a circular economy? We have been developing this first facade test bed for the food industry in the headquarters of one of our clients in Lisbon. In this case, the spirulina is cultivated, you remetabolize the air of the environment, but also it produces biomass for food consumption, but also for the production of biomaterial, packagings, and bioplastic. These are some of the images of the headquarters. These are some of the vision of how the project can be expanded at the whole biofactory scale, where not only we have a system of sensor integrated, but also a system of actuator able to provide a cyber gardener. When architecture becomes capable of synthesizing resources, it is no longer a container or program or function like in the modern machine for living of Le Corbusier, and becomes itself a dynamic process of production, a living machine. This translates to the aspect of the city and how can this biofactory scale up and become part of a new form of synthetic landscape. This is what we investigate in the project of Tallinn, where we started from the water infrastructure. We mapped the existing one that you see here, and then we simulated how a system of decentralization could take place for the processing of the wastewater of Tallinn.
I think what is important to notice here is what happens when we begin to scale to the urban realm, the impact of transforming buildings into active agents of production and no longer just containers of function. And what happens is that the urban infrastructure transforms itself from the centralized system that we have today, as you can see here in the drawing, into this kind of a distributed intelligence. Into this form of complex emergent intelligence. And so this kind of new logic has potential to transform completely the way we understand cities and we understand the built environment and the fabric of cities. And this is a vision, as Claudia was mentioning, that we have developed for Tallinn, the Estonian capital, and that was exhibited also as a part of the Biennale of Architecture of Tallinn, curated by Claudia and designed by our office.
The model that we use to simulate the redistribution of resources refer to the Fusarium polycephalum. Fusarium polycephalum, or in common terms slime mold, is considered by many the next biological computer, as it's able to optimize resources in a bottom-up manner through the interaction of millions of its nuclei, and not through master planning or top-down decision making. Here you can see a simulation of slime mold we have developed for the city of Tallinn, which is the one that then informs the algorithmic redistribution of the city. In the case of slime mold, as Marco was mentioning before, aesthetic become a dimension of its ecological intelligence. In the later here, we started to translate the intelligence of the slime mold to artificial intelligence algorithm, in particular here to machine learning algorithm, in which we, through the observation of the slime mold, we translate the information, the behavior, and the pattern to a machine learning algorithm. This is applied to Venice.
With this design strategy, we are essentially trying to bring a new perspective into the way we envision and we understand cities. And I think this is really a way of shifting the understanding of intelligence from kind of human-centric perspective to a non-anthropocentric one, if you want. And this, of course, is significant in the moment we are trying to imagine how to embed a new resilience into cities, into urban infrastructure. But also as we begin to understand and read the patterns of urbanization, the urban fabric in a different way.
This is an application that we are developing over the city of Paris together with the city.
This is a video that has been generated partially through biological growth of our culture of slime mold, and partially through a long computational process using machine learning algorithms. And during this process, the algorithm learned the behavioral pattern of the slime mold and became very proficient at rereading or reimagining the satellite view of Paris through a new lens, so through the logic of the slime mold and its growth patterns. And so after recombining many hours of computation and many frames, we were able to create this computational video that effectively reveals this new perspective for the city of Paris. The video also goes through different scales. So it starts from a frame of 10 by 10 kilometers, and it begins to zoom in by a power of 10 until it reaches a scale of 100 meters and focuses on the Saint Pompidou building itself, retransforming its architecture, systems, and infrastructure into a new living and biologically active organism. As you can see, the algorithm is able to recognize and pick up the materiality and the organizational pattern of the urban fabric of Paris, but then it reconstructs them, reorganizes them following the logic and pattern of growth of the slime mold itself.
Here you can see it's operating at the scale that the infrastructure to describe it. 100 meters square.
scale of Paris. And here are some still images extracted from the video at different order of magnitude.
These methods question traditional planning concepts such as zone, boundary, scale, typology, and program. Such outdated notions constrain the emergence of a systemic approach to urbanization, not recognizing the true nature of contemporary city as complex, dynamical system. This brings us to the last project, I think, that we are presenting today. It's a project we are developing with the United Nations Development Program. In particular, this is an application of the GAN-Fusarium algorithm and a few other data gathering techniques to the redesign of the city of Guatemala.
Yeah, the project essentially demonstrates the possible application of this protocol. And in the case of Guatemala City, we were able to investigate how this could be applied as a technique for rewilding. In Guatemala, there is a very critical, let's say, conflict between infrastructure or the failing of infrastructural systems and the fragility of the local landscape. The city being built on a quite steep valley and on a very erosional soil. And so these criticalities really call for a new understanding of how infrastructure can be built around a new conception of the urban landscape.
So here we are mapping the distribution of the waste network, looking at how different points can be mapped and decentralized, connecting directly to the inhabitation. So these are different algorithmic protocols that connect waste disposal center with the inhabitation terminals of the city of Guatemala. This algorithmic procedure has then been used to train and transfer to artificial intelligence algorithm that allow us to have this future satellite view of Guatemala City, how Guatemala City can be transformed in its network, in its topography, to the redescription of the water and waste network, and therefore the redescription of its geological system.
And in this way, effectively, we are invited to look at urban infrastructure as a part of this geomorphological system rather than in opposition to it. So I think this is the last slide for our lecture so far. I hope it was not too long. I know it's always quite difficult to follow remotely, but we tried to be as clear as possible. But of course, we are happy to take some question and further comment if you wish us to do so.
Genial, pues fantástico. Muchísimas gracias, Marco y Claudia.
Great, wonderful. Thank you so much, Marco and Claudia. Well, I'm just going to remind everybody, for everybody that just connected to the live transmission, we're with Ecologic Studios, made up of Marco Poletto and Claudia Pasquero, and they have carried out a very interesting presentation on the work they're developing, and Ecologic Studio has focused on extending an idea of what space means in urban areas and life itself. So let's open the colloquium, and I'd like to structure it with all of you, focused on 8 relations, 8 implications of your work. And the first one would have to be the relation with history itself. So in some previous statements, what I've heard, well, in a recent analysis of recent history, you have detected that modern movement and that health awareness of the modern movement had deformed the idea of nature that exists from that point. So, in one way or another, it had built a lineal nature as if it was a machine. So, the first question for you is, for you, what is the idea of nature that exists today in the heads of architects, and what do you think should be the role of nature in society?
Well, we often refer to the definition of nature by Slavoj Žižek or Timothy Morton, so the paradigm that nature as a cultural paradigm of reference or untouched by human being does not exist anymore on planet Earth. We rather often talk of biological organism or non-human organism and how we could interact with them. In that sense, we have created the word urban sphere. So how there is a relationship between the biosphere, so the whole ecological ecosystem, and the urban sphere, that is the network of information, matter, and energy that has been generated by the global city and the interconnection between global city and drop the planet. And it's out of our control, although it's something that has been triggered by human action, is out of the control on human action. So we are rather interested in understanding how we interact with this form of synthetic nature, rather than creating a separation between the landscape and the architecture, the natural and the artificial.
Yeah, and when it comes to architecture, sorry, maybe I just want to add one element. When it comes to architecture, I think that the concept of nature is also shaped very much by the history of technology and how architecture has ended up adopting that. And if you look in the paradigm of design, the advent of computing or digital design has paradoxically created an even bigger, let's say, contradiction, because it has given us the illusion that we could simulate, we could recreate nature in our virtual environments, and from there we could somehow control it or manage it in a positive way. And I think what the conceptual and cultural paradigm that Claudia was mentioning has revealed, but also very much the fact of the last year and a half has revealed, is that we are not in charge. We cannot fix the planet. We are not the ones who are in charge of fixing the planet. We are only here temporarily on this planet, and our existence, for me, is dictated by curiosity to engage with the systems of nature which we are part of, to essentially understand in a more profound way how they work and in which way we are part of these. And so in that sense, for me, there is also a big excitement in the advent of artificial intelligence and on the possibility to apply these techniques to design and to architecture, because finally we have the tools to get rid of these abstract reductionist CAD environments, or these kind of artificial world where we think we are in charge, and we can engage with data, with design, with science, but in a much more speculative and, of course, non-linear, non-anthropocentric way. And I think this, for a designer, is very exciting. For an architect, it's very exciting. It gives us a whole new perspective where we can deploy our skills and our vision to the contemporary issues.
Me parece muy interesante este desplazamiento de
I think this movement of anthropocentrism is very interesting, and it has to do with a political relation of your practice with the present. I'd also like to have you talk a little bit, well, you've advanced in the presentation on issues and topics that have to do with profound transformations that you propose within life of people, the subversion of life, fun, and environment. Now, within this will of integrating these, what you call the non-humans, I'd like to hear, well, just as what's happening today with the role of other non-humans or non-biological, such as robots, countries such as Korea are building them. So perhaps there could be a definition of a legal framework between them, robots. So do you have some ideas in the definition of relations or frames of relations that can be established precisely between human beings and non-human living beings, such as, well, a type of protocol perhaps, or, well, yeah, a regulatory framework that nuances this relationship, because there could be some ethics, and we've seen natural disasters, for example, volcano eruptions and others have destroyed cities. So how can we regularize this relationship between the human and non-human life?
Well, our work focus on the spatial articulation of human and non-human life. Of course, we are designer, we are not legislator. So for us, the architecture we built is not discovering necessarily new science about non-human life, but is effectively creating a interface of possible conversation between human and non-human. A conversation that is spatial, so is spatially organized, and not regulated by protocol or laws. And these I leave to politician or legislator to, tackle this issue. For us, what is important is when infrastructure is designed and therefore processes are open and unveiled. In that way, we can establish a different level of understanding of them, a level of understanding that Greco Bateson discuss in Steps Toward an Ecology of Mind, to which the name of our studio refer, as meta-languages. So design is not about making, maybe biotechnology prettier for the sake of it. Is about really establish new material languages where processes are unveiled, and therefore we understand them in a deeper manner. By understand them in a deeper manner, we could become opportunistic about them, and therefore establish new ecology, establish positive change rather than disrupted one, the one that everybody call climate change. So the question is, how do we establish this positive dynamic through architecture? And our architecture really aim at becoming an interface, a material interface between these different life forms.
Well, I guess this is also very important because it's about enlarging the framework for discussion on what is artificial intelligence or what is automation, what is their definition within a kind of let's say spatially redefined framework. The problem is that now, of course, these technologies appear to most people as totally obscure. They are like black boxes. We all have them in our mobile phones. We'll all, carry them around. So somehow we are already cyborgian. We are already embedded with AI apparatuses. But our ability to enter a conversation with these technologies or to contribute to the definition of what they can do for us, it's very limited, if not zero, because of course the industry has evolved within a paradigm that is, as we said before, still very much reminiscent of the first industrial revolution. This kind of innovation takes place in labs, in factories, behind closed doors, is protected by IPs and so on and so forth. So the question of how do you unpack that becomes for me a very important question. And architects, urban designers are really, in my mind, the main actors in providing another framework, a spatially open and materially defined framework whereby pretty much any one of us can begin to contribute to a new definitions of what these technologies can do. So that, I think, it's why we are also very interested in engaging with these new tools and techniques. It's not just a question of wanting to be at the forefront all the time necessarily, but it's just that we see that there is a huge opportunity on one side, but also very much a necessity to unpack, to present these kind of technological developments in a different light, because otherwise the risk is that we as a society will never learn how to deploy these new technologies into a framework that is actually conducive to life, and it is actually fostering diversity and both biological and cultural, and so that's for me the one of the key motives that I think moves us into this direction.
Me parece interesantísimo.
I think it's truly interesting to reclaim space of design with biotechnology, with translators of this to open the black boxes through design to reveal a series of situations that are happening. I think it's super interesting. And also, there's another issue, which is a relationship with technology. And that also, it's built its own language, not just in the sense of words. I understand that what you do is you translate that. Well, I know that there's a graph language itself, which are not typical architectural drawings, some cartographies, maps, etc. I'd like to ask you about the technological design with the world of big data. Well, it's obvious that you're also established there, pioneers in linking with big data, and also the space that you're developing these relationships and what you're showing and demonstrating this, revealing this, and has to do with art, museums, and also I'd like for you to go more into this, the relationship of big data and the scenarios you're finding to reveal, to communicate what you have learned and what you've discovered in this type of situation.
Yeah, I mean, thank you for this. I mean, of course, there is again aspects of our work that is very much involved in the processing of data. And again, when you talk about big data, of course, that you are referring to another very specific, in a way, technological realm, which is already kind of dominated by a set of companies, and there is already established protocols. And, of course, they are very much connected with the idea of smartness and smart cities and smart infrastructures. And, again, for us, the main curiosity for diving in that level is precisely to begin to unpack or subvert these definitions. We believe that data only make sense if they are connected to a material substratum, if they are geo-referenced to processes and locations in the real world, and that essentially can be reconducted to the spatial and material experience that we have of our cities. And often, I would say in a majority of cases, when you talk about smart cities and big data, urbanism, you will encounter a level of abstraction that makes the data as well as the outcome of these processes completely disconnected from the material processes, the social systems, the spatial organizations of our cities. So in that way, we believe that, again, there is a really big missed opportunity in terms of using big data to actually really develop new perspectives on how to understand and interpret the complex living organisms that our cities are. So effectively, I think that's how we somehow ended up engaging with this topic very much as an extension or as a continuation of the material research that we have been doing in looking at cities and infrastructures as a sort of a continuum with the living systems and substratums and that underpin our cities.
Fantástico. Otra cuestión que no tengo mucha...
Great. So I don't have many more questions, but what I'd like to do is, well, I don't want to extend too much, but I think it's interesting to get into details of your work, which can be useful for the workshop, and perhaps it can establish relations with the well-being, which is one of the latent subjects, well-being. So one of the explanations of your work has to do with the built environment. So you mentioned it in this conversation. You already mentioned it. You see that you have a very strong presence in the building of interfaces. So I believe, in a little sense, this is transferred to this outer layer of buildings, right? That skin, so to say, that relates the interior with the exterior, and where you are the intermediaries thanks to your devices. I'd like to know what you feel is the potential that your perspective, your work has for the development of projects, of buildings, of constructions, of materials, materialization in a more extensive manner. Let's say that they have a presence or that they use a comprehensive part of the building. Within this, it's very interesting to think how this idea of construction has transformed into a double head, because your office is design, but it also sells products.
Well, most of the time are design and or are elements that are very site specific. So, for example, before we discussed the playground, and in the photosynthetic playground, air bubble that we developed in with Ultravin and GSK, the architecture itself became a transformative agent of the air, or remetabolize the air. Is the architecture that interacts with the environment, the kits that interacts with the algae with the architecture. It's not an architecture on top of which we apply a product, a biotechnology. It's an architecture that integrates a biotechnology. Without the architecture itself, there is no remetabolization. So it's the way people interact with it, it's the way the air flows that create this remetabolization. As Marco was saying before, there is a reduction of between 75 and 95% of the PM2.5, and other elements that are present in the air that the algae may remetabolize or can nurture on. So we call them generically pollutant because they are not healthy for human beings, but they are actually food for other organisms like the microalgae. But the microalgae alone cannot interact with the space and with the human. They are very small. So architecture acts as a mediator in which we can, perform activity that allow us to change the world that surrounds us. So it's really important to for us to zoom out from the idea of product that we can consume and dispose, and they are closed product, to the concept of interacting with space that are transformative and dynamic in itself. Yeah, so in that sense, design becomes a really important element in defining specific condition or specific point of remetabolization.
Yeah, and also the kind of relationship between site specificity on one side and, you know, scalability or the possibility for a technology to be reproduced on the other side also becomes more interesting, because in traditional terms you would say, okay, you know, products is something that you can just, you know, scale up and repeat a million times. In architecture you can't, because it's one-off, it's site specific. I think we're actually more and more trying to find a space in between, whereby we create systems or material systems that are adept at a certain let's say function, or that are they are embedded with let's say certain agencies or abilities, and then depending on the actualization that we are involved with, then obviously there is a kind of a process that leads to a specific instance or to a specific you know, pilot scheme or installation and so on. So in that sense, we are kind of really operating in what I call the design innovation framework. So there is an element of innovation that comes before the project, and that we kind of develop and engineer to have certain abilities, and then there is a process of actualization that it tends to be more site specific, and where, you know, these abilities are actualized and become effective in a certain context, no? And I think this is an interesting. This actually creates also an interesting new, let's say, kind of relationship between the designer or the architects and the client, or you know, let's say the contractors. Because let's say architects are no longer the kind of in between, or the ones who are kind of waiting for the project to come and then they are sort of managing it, but it's a much more proactive role. Like, you know, all of a sudden we bring something to the table that is innovative, that has abilities, and then together with the team that forms around this, we make something happen. No, so that's, I think it's also a more exciting position to be in, and a much more proactive for us and for our discipline.
Entiendo. Bueno, me dicen que no hay tiempo para
Right,
más.
I understand. Thank you. Yes, we have to wrap up. Yes.
Yeah, we understand the Spanish.
Cerramos.
Solo quería hacer una última.
So I just wanted to point that last thing out. I'm seeing with great interest that in almost all the communication of your work, there's a lot of interest for children. So almost all your projects have children's pictures, which is not that typical. So I believe that there's an interesting proposal in understanding that well-being has to do with the idea of education, of teaching, of education that will help bequeath those coming with a better future. So then, with this reflection and thought, I'd like to thank you for your time, your generosity, your sincerity, and hope that we see each other once again in other meetings such as this, and that we hope that your work will be an example for all the students that are participating in the workshop during this week. Thank you so much. Thank you once again to everybody that are seeing the transmission and retransmission from YouTube and other social media. And I will leave you with the invitation for the next talk. Sebastián Rojas Navarro will present on well-being, and it will be introduced by the Dean of the University, Professor Ricardo Aguabat. So Thank you very much. Thank you, everyone, and we'll see each other soon. Thank you.
Thank
Bye.
you. Thanks for the invite.
See you.
See you soon. Bye.